Why does a moving object keep moving even when nothing is pushing it? Welcome to Mattermosaic, piecing together the universe, one discovery at a time. Today, we are exploring inertia, the fundamental principle that explains why motion resists change. The idea of inertia did not begin with modern physics. In the 4th century BCE, the Greek philosopher Aristotle argued that motion required a continuous force. According to this view, objects should naturally come to rest unless something actively kept them moving. This explanation dominated scientific thought for nearly 2,000 years. It was taught across ancient Greece, the Roman world, and medieval Europe, yet it relied on logic rather than experiment. A turning point came in the late 16th and early 17th centuries in Italy. While working in Pisa and later Padua, Galileo Galilei began testing motion using inclined planes. By reducing friction, Galileo observed that objects continued moving farther when resistance was minimized. This led him to a radical conclusion. Motion does not need to be sustained by force. Instead, resistance is what stops it. Galileo's insight laid the foundation for a new principle. In 1687 in England, Isaac Newton formalized this idea in Philosophia Naturalis Principia Mathematica. Newton's first law of motion stated that an object will remain at rest or continue moving at constant speed in a straight line unless acted upon by an external force. This resistance to changes in motion became known as inertia. It depends on mass. The greater an object's mass, the more inertia it has, and the harder it is to change its state of motion. Inertia explains why a stationary book stays on a table until pushed, and why passengers lurch forward when a moving vehicle stops suddenly. These are not separate effects. They are direct consequences of the same physical principle. Inertia has been confirmed repeatedly through experiments, from early mechanics laboratories to modern space missions. In orbit, where friction is nearly absent, objects continue moving indefinitely, precisely as Newton's law predicts. Inertia shows that motion itself is not fragile. It is stability that requires explanation. Change happens only when forces intervene. What feels like resistance is actually nature's way of preserving motion. This is Mattermosaic, piecing together the universe, one discovery at a time. If this explanation clarified something you have always observed but never questioned, share it with someone who values evidence over assumption. Follow Mattermosaic for more precise stories from the foundations of science.